So let's move on towards our next topic of discussion of today. We are going to study this particular paragraph in today's class. Okay. So phenol was used in the 19th century by Lister as an antiseptic in surgery. What does it mean? What is phenol? Phenol's structure is something like this. Phenol's structure is something like this. So phenol was used in the 19th century. And what is 19th century? The period starting from 1801 and ending at 1900. This particular period is called as 19th century. Okay. So phenol was used in the 19th century by Lister. Lister is the name of the scientist. So Lister Lister in the 19th century used phenol as an antiseptic in surgery. Antiseptic, what does it mean by antiseptic? Antiseptic is a compound which prevents infection. Antiseptic compound is a compound which prevents infection. Okay. So as an antiseptic in surgery, he was using phenol. This particular scientist Lister in the 19th century, that is during this period. And aniline looks something like this. Okay. And aniline became the basis for the dyestuffs industry. So the dye industry, what does it mean by dye industry? Dye industry means coloring industry. Okay. So it is something related to dye stuffs industry, so something related to the dyes. Okay. And so aniline became the basis for dye stuffs industry. So many types of dyes were being made out of aniline. Okay. So starting from aniline, many dyes were being created during this 19th century. So it was this that really started the search for new organic compounds. So this use of phenol and use of aniline started the search for new organic compounds. It started the search for new organic compound made by chemists rather than by nature. So right, till now majority of products that were being used till now the majority of products that were being used, they were natural substances. Majority of the things which were being used, those were natural substances till now. But from this particular period onwards, when phenol and aniline came to be used in large amounts, so this actually provoked the search for new organic compounds that were made in laboratories and industries, and rather than being derived from nature. Okay, produced in labs and industries rather than derived from nature. So scientists wanted to move towards artificial substances. Okay. So in 1856, while trying to make quinine from aniline, now quinine, I have already told you why quinine was important. So in 1856, what happened is that while trying to make quinine from aniline, okay, so a person was attempting to make quinine from aniline, and that person's name was William Perkin. Okay, so William Perkin was trying to make quinine from aniline. He was trying to produce quinine from aniline, and during that time in 1856, he was 18-year-old. During that time in 1856, he was 18-year-old British chemist, and his name was William Perkin. And that person William Perkin was trying to make quinine from aniline. But during that, as he was performing experiments to accomplish this, he managed to produce a mauve residue, mauveine. Okay, so he managed to produce a mauve residue, mauveine. Okay, which and it revolutionized. What is mauveine actually? Mauveine is a mixture of many compounds. Okay, mauveine is a mixture of many compounds, and one of the constituents of mauveine looks like this. Okay, have a look. This is one of the constituents of mauveine. Okay, so it is written over here, one of the constituents of mauveine. Mauveine is a collection of, it is a mixture of 12-13 compounds. Okay, mauveine is a mixture of 12-13 compounds. So while trying to make quinine from aniline, he accidentally produced mauveine. Okay, and this mauveine was a type of artificial synthetic dye. Mauveine was a type of synthetic dye. Synthetic dye. So mauveine was a type of synthetic dye. Okay, and it revolutionized the dyeing of cloth. So this particular substance mauveine revolutionized the dyeing of cloth, and it gave birth to the synthetic dyestuffs industry. Okay, so it revolutionized the dyeing of clothes. It was something like purple color or something like that. It was purple color dye. It was almost purple color dye. Okay, so it revolutionized the dyeing of cloth, because till now very few artificial dyeing agents were available, and mauveine was one of the few artificially produced dyeing substance. Okay, so the speciality of mauveine was that it was a synthetic dye instead of a natural one. The the uh, the benefit of mauveine was that it was a synthetic dye, it was not a natural dye. Okay, so that was its characteristic, its important characteristic, and this revolutionized the dyeing of cloth. Okay, and it gave birth to the synthetic dyestuffs industry. So to the synthetic dyeing industry, this was a major accomplishment. Okay, and a related dyestuff of this kind. Okay, so similar to mauveine, another dyestuff is there, which is still available. Although the usage of mauveine has decreased, has decreased, but during the same time, Bismarck brown was discovered. Okay, the use of mauveine has been minimalized nowadays, but a related dyestuff of this kind, related to mauveine. Okay, so during that period itself being discovered, another dye which was discovered along with mauveine during the same time period, and it is still in use. Mauveine is no longer in use, but another dye which is still in use, and it is related to mauveine by the fact that it was discovered during the same time. So related dyestuff of this kind is still available is Bismarck brown. The structure of Bismarck brown has been shown here. Bismarck brown's structure has been shown here. Okay. So a related dyestuff of this kind still available is Bismarck brown. Much of the early work on dyes was done in Germany. Okay. So, and this is another statement. Much of the early work on dyes was done in Germany. So much of the early work was done in Germany. Although in other places also the work was done, in other places also the scientific work was being done, but Germany was in the forefront. Germany was in the forefront of the scientific work. Germany was in the forefront of the scientific work on dyes. Okay, Germany was in the forefront of scientific works being done on dyes. Okay, so much of the early work on dyes was done in Germany. Now let us understand this particular paragraph. What does it want to say? Okay, so it is talking about William Perkin. So Perkin was studying in London. London is in United Kingdom. London is the capital of United Kingdom. So Perkin was studying in London with the great German chemist Hoffman. So along with the great German chemist Hoffman, Perkin was also studying in London. Perkin's attempt to make quinine. Okay, so Perkin was trying to make quinine. From aniline. Okay, so if using aniline as a starting material, he wanted to produce quinine. So Perkin's attempt to make quinine this way was a remarkable practical challenge. So Perkin's attempt, although he was attempting to make quinine that way, but it's his attempt to make quinine this way was a remarkable practical challenge. It was a very huge practical challenge, because the structure of quinine was still unknown. During that time, the structure of quinine was still unknown. Yet he was trying to make quinine from aniline. Although he did not know the structure, still he was trying to synthesize quinine out of aniline without knowing its structure. So it was a practical challenge. It was a remarkable practical challenge, and he accepted that challenge and he went on to do that. But instead of making quinine, he discovered mauveine. Okay, instead of getting the original work of making quinine, and instead of getting that work done, he accidentally discovered an artificial dye. He accidentally discovered an artificial dye called as mauveine. Okay, although he did not want to do that. He wanted to synthesize quinine from aniline, but accidentally he discovered mauveine. And mauveine is an artificial dye. Okay, it is not a natural dye, it is an artificial dye. So structure of Bismarck brown, you can have a look. One of the constituents of mauveine, its structure is given. Okay, benzene structure you must know, pyridine structure you must know, phenols structure you must know, aniline structure you must know, hyophene structure you must know. Okay, so we will learn about the next paragraph from here onwards in the next class. Thank you very much.